All right, so redoing 13.7. On 13.7, we're talking about describing our distributions. Now, it asks for us to take a survey of all the pets in the class, calculating those numbers, sharing those numbers. I figured that was going to take about 25, 30 minutes, and we don't want to take that amount of time when we can be focusing in on what we're doing. So I made up my own results of an imaginary pet survey for 23 students that we would have in our class. So I'm not saying that this is how it would come out. I'm just saying this is the numbers that I use and that I chose on my own. So when I filled out my data chart, we had the option of between 0 to having 4 pets, and everyone fed into those categories. So once again, to save time, I came up with this information on my own. So we're going to say that we had 0 students in our class that have 0 pets. Everybody has at least 1. And then I have one person that have, or 4 people, excuse me, that have 1 pet. You're filling this in your book. I have 9 people that have 2 pets. 7 people have 3 pets. And then 3 people have 4 pets. And I know there are some of you that have many more than just 4 pets. So this is, once again, just numbers I came up with to try to help us understand what we're talking about when it comes to looking at the distributions of data. Once I have that filled out, 0, 4, 9, 7, 3, then I can start looking at the questions. Well, what statistical question could you use for your data to answer? So once again, we have to think about what statistical questions mean. Statistical questions are questions that we ask. This, I believe, goes back to 13.1. May have been chapter 12. Now I've gotten a little confused. It's spring break. Anyway, we go back, and statistical questions are questions that the answers could be a variety of things, not a specific one. Okay? How many people have dogs? That's a very specific question in our that would pertain to our class. We don't know. Wasn't included in our data set anyway, but that is not a statistical question. How many different people have this many dogs, or so on and so forth? A statistical question we can ask about this one, I'm giving you 2 different ones that you can write down to remind yourself what statistical questions would be. What would the mean of this group of data be? So I could get an exact answer for this data, but let's say 2 people were absent today when I did this survey. I don't have their numbers. Then the following day they're there. My mean would change. So I have a variance that could happen. I could do the survey in Barker's class, Ross's class, Reiner's class, and I'd probably get different results and therefore have a different mean. So my variance, I would have a wide variety of possible answers when it comes to that. Another question that I could ask, what would the interquartile range be? How many were close to only having 1 or 2 pets compared to multiple pets? That once again would change according to who's here, how many are here, which class I'm asking. Since I have a wide variety, then that's going to be a statistical question answer. What is the temperature today? Does not tell me, because I have a variety, or I don't have a variety of answers. I have one temperature for right now. All right, so you can graph your data set. I put the data set back down here. To see the center spread, the overall shape of the data. So the center, the spread, and the overall data. Then they tell us either use a dot plot or a histogram. Well, I'm going to use both just so we can remember what they mean. What dot plots are compared to what histograms are. So I'm going to start with a histogram. Okay, so a histogram is once again fact boxes that touch one to another. A bar graph, skinny boxes where there's a space in between them. After skinny box, space, skinny box. Okay? So a histogram has to have boxes that are touching and they're shaded in. How will I label my graph then when I create it? Well, when I'm looking at what I'm talking about, I'm going to look at the possible answers. My possible answers are 0 to 4. So at the bottom, I would label it from 0 to 4 with numbers, and then this would be my possibility. So what is this talking about compared to what this is talking about? My x-axis would be talking about the number of students, or excuse me, would be talking about the number of pets, and my y-axis would be talking about my number of students. So I'm going to have to label it according to number of pets going across the bottom, number of students in my outcome going up the y-axis. And then I plot my information. And once again, we're making a histogram, so I have to do fact boxes that touch 1, after another. So I don't have any that had 0, so I just skip it. I'm not going to mark 0 in any way, shape, or form. So there's going to be a gap there, which we'll talk about in a moment. Then I start building. For 1 pet, we had 4. And then for 2 pets, we have 9. And then for 3 pets, we have 7. And then for 4 pets, we only had 3. All right. So with that information, then I look at the second possibility. I don't care which one you put down in your book. You can put this one down in your book, in that workspace, or you can put the next one that I created. It's up to you. But you'll have to pause the video on the image and make sure you have it drawn correctly, whichever one you choose. On the second one, then, we're going to go ahead and do the dot plot method. So that's where we put a dot for each of our possible answers. So my possible answers range from 0 to 4. So I make kind of like a little small number line. And I had 4, so I put 4 dots. And then I have 9, so I'm going to put 9 dots. And then for 3, I had 7 dots. And then for 4, I'm going to have 3 dots. So my dot plot, once again, shows my possible answers, and my dots are my outcomes that I would use. Either way, then, if you use the histogram or the dot plot, we can answer these questions. I'm going to use the histogram. Now, once again, you have to go back here and pause the video and get this filled out if you chose the box or the dot plot method. You come and ask me for questions, I'm going to ask to see which one you chose, and then we'll talk through it and explain it, how we came up with it. So make sure you have one written down in your book. So then we can answer the questions about it. We have 4 different questions we're going to answer. Are there any clusters? Are there peaks in the data? Are there gaps in the data? Does the graph have symmetry? All right, so question by question, we're going to answer on these 2 lines. Are there any clusters? Yeah, the majority of the answers for the clusters are between 1 and 4. It's where everything is located. So that would be my cluster. Are there peaks in the data? There are peaks. The tallest point. And if you say, well, explain how you know it's a peak, your answer would be because it's the tallest point. There is one peak, and that peak is getting up to 9, where we had 2 pets for a class member. Are there gaps in the data? There is a gap, and that's why I had a couple that had 0 as answers. I don't have anyone that had 0 pets. Okay? So I know there's a gap at the 0. Does the gap graph have symmetry? This one doesn't have symmetry, and I designed it that way on purpose because that's not always going to be a yes answer. I can't divide that down the middle and it look the same. Yes, I go up and then I reach the peak and then I go down, but then I go down again, and it really doesn't balance out. Now, symmetry does not have to be exact. Okay? It doesn't have to be step by step by step looking exactly the same way. But they have to be very close to one another. We'll see that here in just a couple of minutes. Now we go on to find our measurements then. The mean, the median, the mode, the interquartile range, the range of the data that we collect. So we're going to go back to our data chart, our histogram, fill in this information. What is the mean? Well, what is the mean? So mean means, hopefully all of you had the word average pop into your head. Mean means average. I find the total of all my data, and then I divide it by how many are there. So when I look at my information, I had a whole bunch of little numbers. 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, 3, 4, 4, 4. Each of those numbers then have to be added together. This is where your little handy dandy calculator comes in very handy. Add all of those together, I'm going to tell you, you're going to get 55. A total of 55 gives me 23 students because we had 23 numbers written down. And that's going to give me 2.39. Now, as I said yesterday when a couple people asked in class on the answer that was a long decimal number, we focus mathematically. It's called the scientific notation, but we go out 1 decimal point. Okay? So if I'm going to go out 1 decimal point, I have to remember how to round. That takes us back to the first month of school, which we're going to be reviewing here in a couple of weeks once we get through chapter 6. 2.39, then I'm going to round to my 10th position, which is the 3. The indicator is to the right. So this tells me how to round the 3. 0 through 4 tells me to stay the same. 5 through 9 tells me to round up. So I'm going to change my 3 into a 4, and everything in front of it stays the same. So our mean is going to be written as 2.4. Well, my median is finding the middle number. So I'm going to log them off and get down to the center number. If there are 23 students, then I'm going to go over 11, and it's going to be the 12th number. Because then I would go from the end and come back 11, and it's going to be the 12th number. So my median in this group is just a 2. On my mode, which one was the most often? That's the tallest bar or the peak of my histogram. That's going to be the 2. It's the one that I have the most often for my mode. What about then the box plot information that they asked for? So I have to use the same list of data to do my box plot. I have to know my smallest number, my highest number, my median, my lower quartile, my upper quartile. And I always start with my lowest and my highest number. So my lowest number is a 1, my highest number is a 4. My median we set up above was a 2, because I went 11 over, it was the 12th, 11 back, it was the 12th. So I'm going to mark the 2. Now I have to find the lower quartile. Well, what's the middle between the 1 and the 2? Well, when I go from here to here, I get a 2 again. So like we saw before spring break, I could have, one of my lower numbers that's also my my lower quartile, or in this case, my median and my lower quartile are the same number. So I put 2 lines there. And then I go to the second half from this 2 over, and in the middle of those, I have a 3. So my upper quartile is 3. Make it a box plot. I box in the top and the bottom of those 3 center numbers. That includes the median, the lower quartile, the upper quartile, boxed in together. And then I connect my lowest number to the box, and then I connect my highest number to the box. So what is my interquartile range? So I take my measurement of my highest, my upper quartile, and my lowest, my lower quartile, and I subtract them. Well, 3 minus 2 is 1. Pretty simple. My range, distance from the highest actual number to the lowest actual number, 4 minus 1 is 3. So my range is 3. So I found all of that information about that one set of data that I made up. So now they're going to give us information that we're going to answer the same type of questions on. So examining the data and looking how it's spread out. All right, so Connie asked people their ages as they entered the food court at the mall. Use the histogram of data that she collected for 1 through 5. So here I have 1 through 3 shown. What statistical question could Connie ask about her data? So if I go in and I ask Tommy, how old are you? And he tells me I'm 14, that's a specific answer. That is not statistical. I have to ask a question that could have a variety of answers. I could ask, what age group is least likely to eat at the food court? Now that answer could change. If she did this on a Monday, if she went back on a Tuesday, she may not get the same answer. She very likely would not get the same answer on Saturday, because that's the day where most people are going to be at the mall. Okay? So we have to make sure that we're asking a statistical question. Another one would be, well, what age group seems to visit the most? That once again is going to change. Could change according to time. If I go to the food court during the day at the mall, well, there's mostly going to be adults and retired people. Not going to be a lot of kids because they should be in school. However, if I go in the evening, there might be more kids there. So I have to make sure it's a statistical question. Describe any peak or gap in the data. Well, there are 2 peaks, and I have to have 2 peaks because I have 2 separations of data. My peaks are going to be according to clusters. So my first peak is going to be that 21 to 30 age group. That's where my largest cluster is. The outlier, the one that's by itself then, is going to be 61 to 70 for my second peak. My gap happens between the age group of 51 to 60. So we didn't have anyone in those ages that was at the food court at that specific time on that specific day. Does the graph have symmetry? Explain your answer. Well, there's no symmetry on this one because we have a gap, we have 2 peaks, it really doesn't follow any kind of set pattern. I can't divide the graph evenly to get a balanced look to it. So the answer is no. The reason there's no symmetry. I can't divide the graph anywhere to be evenly balanced. All right, so now we go to 4 and 5. I just brought the graph down. Yours is on the same piece of paper. The lower quartile of the data set is 16.5 years. I don't even have to calculate it. They tell me. And the upper quartile is 51.5 years. Once again, I don't have to calculate it. They tell me. Find the interquartile range. Is it a better description of the data than the range? Explain your reasoning. So I have to find the interquartile range. I also have to know what the range is. And then I can decide which one is the better grouping. So my interquartile range. When I find it, I have to take my upper quartile, subtract my lower quartile, and we're saying that most of the group of the ages that are at the mall is 35 years old. When I look at where 35 is, that makes me question, is that really the best answer? Well, if that's my interquartile range, is it a better description than the range itself? Well, it's not going to be a better description than the range itself because my range is going to include everyone. Explain your reasoning. The majority of the data goes below the interquartile range. If I was here, then most of my information is less than that. It's really not the best description overall. What about number 5 then? It says the mode of the data is 16 years old. That's that's the largest number that was repeated. We don't have our data set. Once again, it's just the information that we're given. Is the mode a good description? Well, when I look at where 16 would be, 16 would be in this group, and we'd have to say once again, no, that's really not a good way to use this description. Okay, if I use the mode, it's not going to, focus in on where my peaks are. Neither of my peaks are in that grouping there. So that really isn't a good way to describe my data either. We're going to get into 13.8 here in a couple of lessons where we look at where they're using data to try to mislead us and misguide us. And we have to make sure that we really understand the data so that we don't get tricked on information. But this is just asking, is this a good way to use our data? No, it's really not. It doesn't give us a good image or description of the type of people that are there at the mall with us. All right, so then they give us a dot plot to look at. Excuse me. So I'm talking about songs, I know that, and this is my outcome. So are we talking about genre of songs, country, western versus pop or rock or classic? Or no, what it's asking about is this scenario. Jason collected data on his classmates, and he wanted to know how many songs that his classmates downloaded in a 3 weeks time period. So we had some people that downloaded 7 songs. We can see a peak there already. So that's the most common number. But we did have one person that only downloaded 1 song in 3 weeks. We had one person that downloaded 13 songs in 3 weeks. So we have all of that information plotted on our dot plot. Does the data set have symmetry? Why or why not? So this goes back to what I just said a moment ago. It doesn't have to be exact when it comes to symmetry. If I draw a line down that center of that graph and look where the 7 is, it is very close to being symmetrical. We go down a step, we go down 2 steps. The only difference is this one would just be added over here to make it perfectly symmetrical. So it still has a line of symmetry, even though it's not exact. It's not perfect symmetry, but it's very close through the 7. So yes, it has symmetry. Jason claims that the median is a good description of his data set, but the mode is not. Does this statement make sense? So the median is what? The middle of the group, right? So if we knock them off and we go to the center number, we're going to find out that the median is 7. Well, what's the mode? The mode's also 7, isn't it? So that's a really bad statement. Ignore that because I found the mean and it's actually the median. So no, that's not a good statement at all because the median and the mode are the exact same number. And if it's the exact same number, one can't be better than the other. So what I actually wrote was no, the mode and the mean are both the same, so one can't be better than the other, which is basically what I just said. So make sure you have those written down so we're understanding what we're talking about. It's not a good comparison saying that one number is better than the other when they're the exact same number. And then that takes us to this one. So notice I've already put my information in order from least to greatest. I'm going to have to be finding my range, my interquartile range. And if I have an interquartile range, I know I have to have a median. So I have to have my numbers listed in order from least to greatest. So on your paper, you need to have, and if I say them too fast, then pause the video and write them down. A 0, 0, 1, 1, 2, 2, 2, 2, 3, 3, 3, 5, 12. Those are all the numbers that are listed up there. They're scrambled. And if I just find the median of this group, it's going to completely throw me off. It's not going to work. They have to be put in order. It has to be step one. If I'm doing median, if I'm doing mode, if I'm doing range, I have to have them in order from least to greatest. Once I've done that, then I can find my median and I can begin to plot my box plot. I also have to know what my lower quartile is. I also have to know what my upper quartile is. I also need to start with my lowest number and my highest number. So I have a 0 and I have a 12 for my range from 0 to 12. My median, we found, we knocked 6 off at the front, 6 off at the back, 7 right in the middle. So the 2 is my median. My interquartile range, so I have to have my lower quartile. In the middle, I have two numbers that are exactly the same. So I know that has to be my lower quartile. And then to the right, and I get to the middle, I have a number that is exactly the same. So I know that has to be my upper quartile. So I have marked 0 and 12, my lowest number, my highest number. I've marked the 2 for my median of my entire group. I've marked the 1 for my lower quartile, which is the middle of the left-hand group. And I've marked the 3 for my upper quartile, which is the median of the right-hand group. Once I have those, I have to box in my 3 that are included for my quartile. So I have my lower, my median, my upper. And then I finish my box plot by making my lines, connecting my lowest number to the box, my highest number to the box. Then I finish my data information. What is my interquartile range? My interquartile range, I have a 3 for my upper, a 1 for my lower, so 3 minus 1 is 2. My range is the overall data set, so I have to go from 12 down to 0. So I would take 12 minus 0, which would give me 12. So I know my range is 12. That's all I had to do to finish that question, which takes me now to my assignment. So my assignment, 749, excuse me, I have 2, 3, 4, 5, 6 on the back. So tonight I have 10 questions. Once again, the 4 on the front that you're doing are reviewing the things that we just did on the video. 2 on the back, so 6 of those questions. The 2 on the back at the very beginning, 1 and 2 are also going to be according to the assignment. The 4 others are going to be review. Make sure you have written down, followed along, paid attention, participated actively, thinking about and listening to what I'm saying while doing your book, and then you may ask.